We will discuss about strings in C. In C language, strings are stored in an array of character along with the null value terminating character at the end. So this null character denotes end of the string. Okay. It is denoted by /0. In C, we have certain functions that can be applied on strings, right? So what are those functions? We have string length, which is used to find length of the string. We have string concat, which is used to add or join two strings. We have string copy, which is used to copy one string to the other string. Then the next is structures. So these structures are a type of user-defined data type. Because it is defined by the developer. For example, I will define a structure called student. So to use a structure, create a structure, we need to use the keyword struct. Okay, for example, struct student. So you can define what a student consists of. Okay. For example, I will write int ID, character, gender, then int section. Okay, so is the first standard, second standard, like that. Then I can write int marks. Like this, you can see. That's why we call it as a user-defined type. Inside a structure, we can use different data types to create this structure. Okay. You can add few more data types relevant for the student. Okay. This is how it becomes a user-defined data type. Now, we will see what is a data structure. A data structure is a specialized way for organizing and storing data in memory so that one can perform operations on it. Okay. Data structure is a specialized way for organizing and storing data in memory so that one can perform operations on it. So data structure is all about how to represent data elements, what relationship data elements have among themselves, how to access data elements, that is, what are the access methods. Okay. And there are different types of data structure. We have primitive data structure and we have non-primitive data structure. Primitive data structures means the primitive data types like integer, float, character, and pointer. And non-primitive data structures are like arrays, files, lists. In these non-primitive, we have again linear data structure and non-linear data structures. Like we have stack and queues, which are linear data structures, and we have trees and graphs, which are non-linear data structures. So primitive and non-primitive. In primitive, we have integer, float, character, pointer. In non-primitive, we have arrays, files, lists. In linear data structures, we have stack and queues. In non-linear data structures, we have feeds and tabs. Then what are the operations on data structures? The operations that can be applied on data structures are create, used to allocate memory for the data elements, then destroy. This operation deallocate the memory space assigned to the specified data structure. Then we have selection, accessing a particular data within a data structure. Then we have update, for updation of data in the data structure. Then we have search, used to find out the presence of the specified data item in the list of data item. Then we have sorting, process of arranging all data items either in ascending or in descending order. Merging, process of combining data items of two different sorted lists of data items into a single list. Now, we will discuss about one very important data structure that is called as stack. So stack is a very important concept in data structures. So what is a stack and what are the applications of stack? So a stack is an ordered collection of items into which new items may be inserted and from which items may be deleted at one end, called the top of the stack. Okay, it's an ordered collection of items into which we can add new items and we can also delete the items from it at one end. It has only one end. Okay, the deletion and insertion both happen at the same end. It is called as a LIFO data structure, means last in, first out. If a person wants to put a plate on a pile of plates, he has to place it on the top. And if you want to take a plate from the pile of plates, he has to take it from the top. So this can be compared with the stack operations. The insertion and deletion both happen from the same end. Then what are the operations on a stack? There are two operations that we can perform on a stack. Push. When an item is added to the stack, then we have pop. It removes item from the stack. So the push adds the item I to the top of the stack, whereas the pop removes the top element and returns it as a function value. So we can implement the stack in two ways. We can either use arrays or linked list. Then we have a queue, another very important data structure. So queue is a non-primitive linear data structure in which elements are added at one end Queue is logically a first in, first out data structure. So when there is a line of people at a railway station, at a railway reservation counter, whenever a person enters the queue, he stands at the end of the queue. Okay, so here the first person to come is the first person to get service. So queue can be implemented as a static implementation or a dynamic implementation. Then we will move to linked list. So as the name says, this is a list of values where there is a link between them, correct? It is a special data structure in which data elements are linked to one another. Each element is called a node, which has two parts. So a node consists of info section, which stores the information, and it has address section, which stores the address of next element of the same type. What are the advantages of linked list? Linked list are dynamic data structures, as they can grow and shrink during the execution time. Efficient memory utilization, because here memory is not pre-allocated. Insertions and deletions can be done very easily. At the desired position. And what are the disadvantages? More memory is required if the number of fields are more. Access to an arbitrary data item is time consuming.